This video is a quick review of the process for simplifying square roots. This is something we talked about back in section 5.4 in the textbook, so if you need additional examples, refer to that section and you should still have your homework from that section as well. This is one of the things you need to know how to do before we get to the next method for solving quadratic equations, which is solving using square roots. So I have three examples, so I'll run through these quickly with you. The first one, the square root of 8/5, this is not simplified because it's a fraction inside a square root. So there are three things you're checking for. We need to make sure there are no fractions inside square roots, no square roots in the denominators of fractions, and then no perfect squares inside the square root. Alright, so this one, the process we used for simplifying was to first write this as separate square roots in numerator and denominator. So square root of 8 over square root of 5. And then we have two choices here. We can either choose to simplify square root of 8. So we need to check and see if there are any perfect squares inside of that square root. The other thing we could do is rationalize to make sure that there's no square root in the denominator of the fraction. So I'm going to choose to simplify the square root of 8 first. So I would write this as square root 4 times square root 2. And I'm doing that because I know that 4 is a perfect square. So that square root 4 is going to be 2. So now the numerator would be 2 square root 2 and denominator is square root 5. And then finally I need to rationalize, so I'm going to multiply numerator and denominator by square root 5. And then in the numerator, that would give me 2, and then square root 2 times square root 5 is square root 10. And then in the denominator, square root 5 times square root 5 is square root 25, which is just 5. And then my last thing I check, I make sure the numbers outside the square root are simplified. So 2/5 is in lowest terms. Alright, so this would be the fully simplified answer. So notice there are no square roots in the denominator. There are no perfect squares in 10, since that's just 2 times 5. And then there are no fractions inside the square root. Next example, square root 3/4. So same thing, I'm going to write this as square root 3 over square root 4. And then square root 3 is fully simplified. There are no perfect squares in 3, right, since 3 is a prime number. And then square root 4, this one's pretty nice. That works out to be 2. And now I don't have a square root in the denominator. All right, so this one is fully simplified. For our final example, same thing. Let's write this as square root 2 over square root 7 first. Square root 2 is fully simplified. But square root 7, that's a square root in the denominator, so I need to take care of that. So I'm going to rationalize by multiplying by square root 7 over square root 7. So in the numerator, square root 2 times square root 7 is square root 14. And in the denominator, that's square root 49, which is just going to be 7. All right, and then as a reminder, numbers inside square roots can't be reduced with numbers outside square roots. So even though 14 is divisible by 7, the square root of 14 is not. So this is the lowest terms that I can get this number. Okay, so that one's done. All right, so that's it. Those are really the three main rules, and I tried to choose examples that will look similar to ones that you'll see as we go through the next problems with solving using square roots.